object I am assigning.
All right, good afternoon, everyone. How did your assignment go? The practice problem I've assigned. Do you have any questions? Please put them on the chat as usual. .2 number 8 and 2.2 number 12. Sure. So the exam grade, I will be working on them over fall break, and I hope to get them that, so you will have them sometimes around fall break. So by Tuesday, I would say. Okay. All right. Okay. Okay, let me pick up the problem that you guys had difficulties with. So it's 2.1, number 8, part E, 2.2, number 12, 7A. The student to ask about 7A have to tell me, Matt, you have to tell me which section this is. Oh, okay. I will start. So first I start with 2.1 because, and it's number 5, number 7. Number 5, 7, 8E. Okay, I'll do those from 2.1 and then I'll go back to 2.2, so I won't get them all confused. So section 2.1, of course, they are all about the domain, which means which input I can give the value x so that the f of x will be a number. That's really what we are talking about. So let's look at number 5 in section 2.1. Okay, so let's see what this is about. 100 people are in a line. Let f be the function that to each number m, assign the number of letters in the first name of the person who is the mth person standing in line. Okay, so we have a bunch of people standing in line. Okay, so that's the picture for us. We have people standing in line. So the line is you have the first person, the second, the third, etc., fourth, and we have 100 people standing in line. And what f does, f is the function that to every person, it assigns the number of letters in the first name. So whatever the person is, let us say John is standing first. So that's number 1, standing in line. So it's going to assign how many letters? Okay, let us say Sam standing number 2, they're going to assign the number 3, and so on and so forth. So
I have a question.
In this case, question?
Were we supposed to do number 5? I don't see it on there.
I don't know. Honestly, I forgot, but I just, I saw number 5, one of you asking for it. Okay, I forgot what numbers, but it doesn't really matter anyway. So the people are 1, 2, 3 up to 100. So they are going by numbers, number 1 in line, number 2 in line, number 3 in line, number 100 in line. So what is the domain in this case? It means what are the input in this case? So f of 1, that's how this works. F of 1 in this problem is 4, according to my scenario. F of 2, it means 2 stand where the person is in line, so it's the second in line. is equal to 3 according to my scenario. And so on and so forth. F of 3, the 3 here, the input is where the person is in line. So whatever the person is in line, whatever his name is, let us say his name is Norma, then the output is going to be the number of letters. So the domain here is nothing more than the bunch of numbers, 1, 2, 3, etc. up to 100. Okay. All right, now I'll go back to the question I've assigned. So from 2.1, I have number 8. I have number 8, E, and 7, A. Okay, I will go over those. All right. So number 7, A. What is 7A here? Find the domain of the indicated function. It means part A. Means you have to find which value of S, what input I can put for S here. What can I put for S? So f of S will be a number. So in this particular scenario, so that's 7A, is there a value that I can put here so that f of S doesn't make sense? What can you say? What's going to be the domain? Which input can I put? Now I get back to you guys. What's going to be the domain? Which input values are allowed? Can I put 1? As simple as that. Put 1. What's the problem? 1 to the power 2 is 1, plus 4 plus 3. Can I put 4? Yeah, what's the problem? Is there a value of S that when I plug it here, I don't get any number? Please, I want answer on chat because you guys ask a lot of questions. I would like to go over them. So what do you think? What's going to be the domain in here? All real numbers. Because no value of X, no value of S is giving me any issues. So the input here is S. Instead of calling it X, they called it S. It doesn't really matter what the name they give to the variable. This function takes a variable, square it, plus 4 times the variable plus 3. So there are no issues in here. Very good. Now we're going to move on to still 2.17a. And which else I assigned here? Right. Okay, now number 8, E. So I will do to 8E. Okay. 8E. Actually, why don't I do 8D? I forgot if I assigned it or not. Let me do 8D and then I will do this one. Okay, 7D. Very good. Okay, let's do 7D. Find the domain of the indicated function. What's the domain of this function? Okay, this function has a denominator. And whenever we have a denominator, we know that every value of X that makes the denominator 0. So if I pick a value of X that makes the denominator 0, I will have something over 0, which doesn't make sense. So what's the domain here? What's the domain? I have to exclude everything. So the domain will be, I'll write it here clearly. I hate to write on my book. So the domain here is what's giving me problem? Everything that makes the denominator 0 is problematic. So the domain is going to be all values of X such that the denominator is absolutely not 0. These are the values that I have to basically take away. So what does it mean? How can I find X plus 2 different from 0? I said, okay, when this is 0, X plus 2 equal to 0, it happened for X equal minus 2. So at this stage, I'm actually solving. When is this is 0? This is 0, so the domain now, all values of X, such that X is different from minus 2. So whenever we have a denominator, we have to exclude all the values that make the denominator 0. So I ask myself, which ones make them 0? minus 2. I have to exclude that. Otherwise, I will have minus 2 plus 3, that's a 1, over 0, which is not a real number. Right, so now let's pick up the other ones. I will pick up E and D. I forgot if I assigned D or not. I don't really remember. So D, the function is equal to the square root of 36 minus x divided by x plus 8. And the question is, what's the domain of this function? It means which axis, which value of x I can put here, and f of x will be a number. All right? So for almost any division problem, I would most likely be finding absolutely, not the x non-value. I will always find the values of x where the denominator is different from 0. Yes. All right. What's the domain here? What can give me problem here? Two things. Every x that makes this 0 give me a problem. So I have to exclude those. Do I have another issue in this function? Do I have another issue in this function? Anybody? Usually for the domain, two ideas give me problem. Every time I have denominator, I have to think a little bit. Any time I have a square root, I have to make sure that what's under my square root is positive. So for example, if I plug in here, I don't know, 40, for example, and I evaluate f at 40, I will get the square root of 36 minus 40 over 40 plus 8. So the denominator is safe because it's 48, but what's giving me? 36 minus 40 square root of minus 4, which is not a real number. Very good. So no negative in the square root. No negative in the square root. So now what do I need here for the domain? I need all the x such that 36 minus x is positive. So what do I need? I need all values of x such this is positive, and I need all the x's such that x plus 8 is different from 0. So to find the domain, I have to look for two things. I want to look for all the x's that make this is positive, otherwise I'll have nonsense. And I want all the x's that avoid the 0. So this is what I need for the domain. All right. Now each one of them. When is x plus 8 different from 0? So I ask myself, okay, when this is equal to 0? This is equal to 0 when x is minus 8. So I want to avoid this value. All right, so on the side, I ask myself, I want it to be different from 0. So when is it 0? At minus 8, I have to get rid of this value. Now, when is 36 minus x positive? How do I do that? How do I solve this? Anybody? No negative under the square root. This has to be positive. So which x's make this positive? Anybody? How do we solve it? I don't know. How would like? Two ways. I said, okay, minus x larger than minus 36. I divide by minus 1. So divide by minus 1 because I want to isolate my x. So I divide by minus 1. But when I divide by minus 1, I have to switch inequality. It means x less or equal to 36. Okay, and now I combine both ideas. So what's the domain? And I'm going to write it up. I don't need any notation. I want x to be less or equal to 36. And I want x to be different from minus 8. So the domain would be all values of x that have the following properties. My x has to be less or equal to 36. If I take any value larger, it will give me a negative number under the square root. So if I take x to be 37, I will have the square root of 36 minus 37, square root of minus 1 nonsense. So I need to every value such that x, and I need two conditions. I want my x to be different from -8, because -8 will make my denominator 0. So if I graph the function, it's going to be kind of a weird function. So if we pick up a calculator and graph it, okay, first, this is 36. So the graph would be x less than 36. And the graph is going to have a problem at -8. So there will be no output here at all, because the function doesn't make sense. And everything else, the function is going to look, I don't know, something, I didn't graph it, but it's going to have like something like that. It's going to be like two pieces. The function is going to be two pieces, because there is output here and there is output here. Yes, I flip sign every time I multiply or I divide by a negative number. So if you have an inequality, you multiply or divide by negative, you flip the sign. Yeah. Absolutely, there is no output here. There is no output. So it will be an open, or it will be nothing. It will be like a gap in the graph. There will be a gap in the graph that eventually in later classes you will call it asymptote, but now don't worry about it. There will be a gap. There will be nothing in here. There is no output. All right. Okay, now I'll pick up on the last one you guys asked, which is number E. So I'm going to write it here, because as I told you, I don't like to write on my book. It's the cubic root of s squared minus 3s plus a half. Okay. Right, what's the domain in here? What's the domain in here? What's the domain? Here I have a cubic root. So let me ask you simple questions. Does the cubic root have problems? It means, can I have the cubic root of -8? Does this make sense? Yes or no? Quickly. No, because why cubic root of -8 make no sense? What's the cubic root? What's the cubic root? It's the number. When you raise it to the power 3, sorry, I thought I took away the phone. Okay. It's the number. When you raise to the power 3, you get -8. Is there a number? That's an odd power. That's crucial. That's odd. Is there a number when you take to the power 3, you get -8? Yes or no? Absolutely, -2. There is no issue with that. So it's well defined. Now, why the square root of -4 doesn't make sense? Because whenever you take a number and you square it, it has to be positive. So this is absolute nonsense, because you're asking which number you square, you get -4. No number you square, you get -4. Any number when you square it, it's going to get a positive number. So the cubic root, actually, whenever this root is odd, we can have a negative number. So the cubic root have no issues. Under it, we can have positive. Under it, we can have a negative number. There is no problem with the cubic root. Why I am talking about that? Why I am talking about that? I'm talking about that to ask us a question. What's the domain? It means, can I put any value I want here for s? Or I can't. The square root, I know I have a problem, because I am only allowed positive number. How about the cubic root? What's going to be the domain? Another word. Can I put 1? Let's try it. 1 minus 3 minus 2 minus 2, you add a half, you get -3/2. Well, there is no problem. Cubic root of -3/2 is defined. Can I put 0? Yeah, 0 minus 0, that's a 0 plus a half. Cubic root of 1/2 is defined. So it means whatever you want, you can put in here. So the domain is going to be all real numbers. there is no issue there whatsoever. For the square root, we have a problem. For the cubic root, we don't have any problem. And there is no denominator in the picture. There is no denominator. Okay. So what's the domain? Everything. You give me a number, I can plug it in here, then I can compute this cubic root. There is no issue with what can I input versus the square root where they have a lot of issues. Okay, now let's move to section 2.2 and look at your problem. Okay, so I'm going to put them, and so 2.2, I have number 12, and I have 8, and that's it. That's what I have from 2.2. Okay, so any questions about 2.1 before we move on to 2.2? So let's move on. Somebody is asking me, the domain is any number that you can square root that would also equal negative? I don't quite understand the question, Zach. So the domain, no, the domain depends. If your function has a square root term, the domain requires everything under the square root to be positive. So if I have x minus 4, the domain is all the x's such that x bigger than 4. And if I have x plus 2 in here, no, sorry, if I have x minus 5 in here, the domain also is going to put another restriction. I want to avoid 5. So if I have a function like this, the domain would be everything bigger than 4 and different from 5 as well. Yes, Chris, you can do that. All right, so let's look at number section 2.2. All right. So we're looking at number 8. So that's number 8. So we have a graph, and they're asking me about the domain and the range. And they're telling me that for f, you can assume that the graph continues forever in the positive and negative direction. So it means I'm telling you that no matter what f is, this keeps going. So okay, that's really how the graph, it keeps going. That's really what that is. It's not stopping in here. So the question is, what is the domain of this function? Okay, I can write here. I'll erase later. What's the domain? It means which value of x have output according to this picture. So if I tell you what is f of 1, we know what f of 1 is. F of 1, yes, we have an output of it. Do we know f of 2? Yes. No matter what x is, we have an output. So the domain is a real number. There is no restriction on the domain here. Now what's the range? The range are all the y values that are output values. All the y value that you can find in x, such that f of x is this y. So all the output value. So what are the output value here? It's from minus 4 all the way up to 4. Because if I give you a value here, let's say minus 5, there is no input that have for output minus 5. That's not in the range. So the range, all values of y, such that, very important, y is between minus 4 and 4, both included. Because according to the picture, minus 4 seems to be included and 4 is included. Now, the second one, I think. What's the domain here? It means which x values you can find the y values in here. So what's the domain? The domain, I'm looking at the x values. Okay. all values greater than 0? Absolutely correct, because if I take an x here, there is no output. So here, all values of x, which are strictly positive. Even 0, I don't have an output. Because the way they are describing the graph, which is something you will see, a graph like this, is keep going forever. There is no output at 0. Now, what's the range? The range is all the y value. So here, if I take a y value here, is this in the range? It means, can I find an input that goes in it? Absolutely not. So all the y values such that y is strictly negative. Okay, so if you have a graph, it's not really that hard. You just look at the graph and you ask yourself. If you have a formula, the problem becomes a little bit harder because we have to think a little bit about it. Okay. So this will take care of that. And then I think one more, and then we can move on. 12. Okay, the 12 is a little bit of a story problem. And let's do it together. So a movie theater has 300 seats. So imagine a movie theater has 300 seats. A ticket to see a movie there costs $9. And I have a function that does the following. To each number n, assign the amount of money the owner of the theater obtains when n people buy tickets. What's the domain of f? And what's the range? So to understand this one, I have to understand what my function does. So what does my function do? So we're going to draw the function. To every number n, it's going to assign, so that's my function. You give it a number, it will assign the amount of money the owner will make from n people buying the ticket. So let us make a table. That's really actually easier. So this is n, which is the number of people buying the ticket, and f of n is how much money, amount of money made from selling those tickets, amount of money made from selling those tickets. So if 0 buy the ticket, how much money? 0. If only one person shows up, imagine COVID-19, very few people are going to the movie theater. If one person shows up, how much money the theater owner is going to make? Nothing more than 9. If 2 people, how many? 18. So the picture is clear. 3 people, you multiply, so what's the 27? I mean, it's just 3 times 9. That's really what we're doing. And go on. What's the maximum number of people that can come to the theater? 300, because that's how many seats. So if by luck, probably next year like now, we can all go. So how much money he will make? 300 times 9, which is 2,700. So that's the maximum amount. So what's the domain in this function? The domain is all the input. It means all the n. So what's going to be the domain in this problem? And what's going to be the range? Okay. The domain is what? It means what goes in here. What are the things that we assign something for? So it's 0 in the domain. What's the domain? Back to you. It means what are the input value here? 0, 1, 2, 3, 4, etc. up to 200. This is the domain. I would not say, in this problem, I would not say a domain is x less than 300. It's confusing because when you say x less than 300, you will allow x to take the value 2.5. In this particular problem, x cannot take the value 2.5 because 2.5 cannot be a person. So that's why this time I wrote it as a list, 0, 1, 2, 3, up to 300, because 2.5 is not allowed. However, it was allowed previously. And what's the range? The range are all those output. So it's a 0, 9, 18, 20, multiples of 9, multiples of 9. Every one is a multiple of 9. That's 1 times 9, 2 times 9, 3 times 9, 4 times 9, and so on and so forth. Okay, so that's the domain and that's the range. Okay. Any other questions? Okay, so today we're going to move to section 2.3. And before I start 2.3, we have to understand clearly what those open circles and open holes and closed hole are about. So this is a graph of a function. So before I start 2.3, I would like to go through that. Suppose this is a graph of a function. So this is the graph of a function f of x. Okay, and you can see some hole closed, some holes open, and so on and so forth. It means that this is the input values, and right here I have the output values. And usually I ask about output. So if I tell you f of 0, okay, this is 0. What is f of 0? Means that's vertical distance. That's equal to 5. That's really what I'm asking. Now, f of 1 is clear. F of 2 is clear. What is f of 3? Okay. When you have an open circle here and a closed, means that the value that the function take at 3, it's what happened when you have a closed circle. So in this case, what f of 3 is, if this is closed, so you go right there. According to my picture, -1. Okay, so it means that the function takes the output at 3 is the closed hole or the full hole, not the open hole. That's how we read those holes. So here the idea reflecting that I want my function to be equal to -1 at 3, but after that my function is really changing. A totally different formula. That's what we're going to be doing today. So, but f of 3, that's what the closed hole means. So according to this little remark, what's the value of the function at 5? What's the value of the function at 5? Please, on chat. 6? Absolutely. That's 6. The closed circle. Now, let me ask you a following question. Suppose somebody gave you a graph of a function and have something like this. Both are closed. What's wrong with that? What's wrong with this scenario? Can I have 2 closed holes? No, because, okay, I'm having 2 answers, so we have to figure it out. What's wrong with that? The question is, suppose somebody show you a graph, and at 5, he has 2 closed holes. What's wrong with that? What's wrong? Okay, what's wrong? I see here no, and the answer is no. What's wrong? No. No, that's not. Who can really point? Right. Grace have it correct. Because an input value cannot have, this is a function. A function, every input should have 1 output. So if somebody show you this graph, you look at him and tell him that's not the graph of a function because the input of 5 is having 2 output. That's absolute nonsense. Okay, so if it's closed here, this has to be open or vice versa. And this, because that's the definition of a function, I cannot have 2 different output for the same input. Okay, so if one is open, the other one has to be closed. That's the idea. Otherwise, it's not a function. Okay. We will talk about that, Zach. All right. So again, before we move on to section 2.2, I also want to do something fairly simple. Suppose I ask you to sketch the graph of the function given by f of x equal to x plus 1, but I'm limiting my domain. It means I want the graph, but I'm only interested in the graph between -1 and 3. So that's really the domain I am working with. How do I graph this? How do I graph this? All right, first to x plus 1. The x plus 1, that's a linear function because it has the form mx plus b. So that's linear immediately because it's x, it's not x squared. So the graph is a line. Graph is a line. Okay. Now how to graph a line? All right, there are several ways. One easy way is a line is determined by 2 points. So if I know 2 points on the line, I can graph a line. So that's one way to graph a line. And I'm going to use this idea today. So if I want to graph this line, I said, okay, this is a line. How to graph a line? I need 2 points, x value and y value. If I know those, so y here is the 2x plus 1. That's really what my y is. I need 2 points. So you can pick any 2 points, but we should be smarter than that because I'm restricting my domain between -1 and 3, -1 and 3 included. So instead of taking any values, I said, you know, let me see what happened at -1, what happened at 3, and then graph my function. So at -1, that's a line. So if I know 2 points, I know the line. That's really the idea. So this would be 2 times -1 plus 1, -2 plus 1, -1. Means at -1, my output is -1. So that's 1 point. And this is closed because it's closed at -1. Now, I need another point. I will take 3 because I can take 4, but it doesn't really make sense because that's really my domain. So I'm going to restrict with it. I take 3, I will get 2 times 3 plus 1. This is 7. So at 3, my function takes the value 7. So let us say 2, 3, 4, 5. Let's see, this is 7. So since I don't have a grade, on your homework, I'll give you a grade. So that's the other point on the line. And that's closed here because I have equality. And so this is going to be the graph of my function. A straight line, absolutely straight line between -1 and 3. I will not keep going. I'm not going to keep going because I'm telling you my domain is restricted. I'm telling you I want it between -1 and 3. Okay. Now, suppose I give you the same function, exactly the same. But I tell you, okay, I'm interested in it between -1 and 3 and open at 3. How will change the graph of the function? So now it's the same. So this is a line. To sketch it, I just sketched 2 points. But here I'm interested only between -1 and 3. I don't care about what the function does outside this. I just care about the function between -1 and 3. So exact. So the thing is that it's actually the same, but at 3, I just open my circle, and that would be my graph. Okay, so if you want to graph a function, which is a line, one easy way to do it is just take 2 points on the line. That's really the easiest way, because if you know 2 points, you know the line. So now how to pick the points? If I'm restricting you, okay, the easy way is to take what happened at those points and then draw the line. Okay, so we're going to draw a line today, but that's to get us started. All right. Today we're going to be interested in function that looks like that. This is the type of functions we're going to be interested in. But before we do this, let me start with a simple story problem, which is verbatim from your book, and section 2.3, piecewise function. Okay. Let's go back to the idea of a function. Suppose f is the function that assigns to each person the number of letters in their first name. Function that, it's showing up a lot. So here, if p represents the person, So P is like a variable that represents a person, then f of P is, according to my rule, what does P does? It associates the number of letters. So it means f of P is the number of letters in the first name. So this is my function, which is given totally by a very simple rule. So if I take f of Kamala Harris, okay, what's f of Kamala Harris? 1, 2, 3, 4, 5, 6. It's equal to 6, the number of letters in her first name. Now, I'm going to make a variation of this. So here, in this function, the output is very defined. For every P, whatever the person is, my output is the number of letters. Now I'm going to change a little bit scenario. I say, okay, suppose f is a function that does the following weird thing, that is assigned to each person. So my input are person, everyone, every person under the sun, every person. The number of letters, if in their first name, if that person is a male. And the number of letters in their last name, if that person is a female. So now I change my scenario. Means if P is a person, what is f of P? I cannot tell you the number of letters in their first name. It's nonsense by now. F of P will depend on P, whether the person is a male or a female. So how can we write this in a mathematical way to reflect this? Because nobody likes a lot of words. How can we write this? The way we write this is like that. We make a big bracket, and we write f of P depends. If P is a male, we have one scenario. Notice where I wrote P is a male. I put it here on purpose. And the second scenario, if P is a female. If P is a male, I'm telling you that I assign the number of letters in their first name if the person is a male. So f of P is the number of letters. So that's how we're going to represent this function, the number of letters in the first name if P is a male. So I'm breaking up my output. So what I assign to a P is broken up depending on what P is. And it's the number of letters in the last name if P is a female. So this type of function where the rule actually or the assignment depend on the input will be called piecewise defined function because they are defined piece by piece. They are defined if it's a male, there is one definition. If it's a female, is another definition. So with this in mind, so if I say what is f of Kamala Harris, okay, so what's f of Kamala Harris? You go back here. You start here. You say, okay, Kamala Harris is a female. So the rule tell me the number of letters in her last name. 1, 2, 3, 4, 5, 6. In her last name. That's what I am picking up. Okay. Now, if I take f of whatever, John Doe, what's f of John Doe? I look at my input. It's a male. Okay, if it's a male, it's the number left in the first name. 1, 2, 3, 4. I get 4. Okay. All right. So that's really what we're gonna be talking about today. So that's really the story problem. Yes. The graph is gonna be broken. The graph is gonna be broken. So let us take an example where the output, instead of being first name and last name, is actually a formula. So I'll start with my first example. And then I hope I can work one with you. Suppose I take a function f of x. And my function is defined this way. I'll pick a bracket. It's 2x plus 1. The output is given by that if x is between -2 and 1. So my assignment, what I assign to an input, depends where the input is. If x is bigger than 1, the output is -x plus 3. So let us first understand this function. So my first question is really try to basically comprehend this function. So suppose I ask you the following. Find f of 0 first. What is f of 0? So now my input is 0. So what's my output? I go back here, ask myself, what is 0? Which property does it satisfy? This one or that one? My 0 is definitely between -2 and 1. So what I assign to it is 2 times x plus 1. So that's how we read this. So first you take your 0 and you say, where is it? Once you find where it is, you say, what's the rule in this case? So it's going to be 2 times 0 plus 1, which is equal to 1. All right, so let me give you probably along those line questions. So suppose I ask you what is f of 1. What would be your answer? Where do you start? You take the 1, you go back up here. You ask, where is your 1? Does this 1 here or 1 satisfy this condition? Which condition does it satisfy? Because I have equal, means it satisfies that. Because 1 is less or equal to 1. So I'm in right here. So f of 1 is going to be 2 times 1 plus 1. It follows this rule. Because 1 is not bigger than 1, of course, it's equal to 1. So it's within this range. So it's going to be equal to 3. Okay. Now, what is f of 2? Okay, I want answers on chat. More than 1. Ask yourself, where is 2? Which condition does it satisfy? This one or that one? Second one. So if it satisfies the second condition, it means what I assign to 2 is given by this rule right there, minus x plus 3. So f of 2 will be, so that's the rule, because that's, so it's minus 2 plus 3, which is equal to 1. That's really how we're going to read those functions. Very good. Let me keep going. What is f of 3? Again, 3, the input 3. Which condition does it satisfy? This one and that one. 2, what's the output? Quickly. 0, because it satisfied this, so I'm right here also. Minus 3 plus 3, this is equal to 0. Okay, that's really the output for 3. Now let me pick, for example, f of, I don't know, minus 3, for example. Neither, absolutely. Minus 3 is not in here, and minus 3 is not in here, so this is undefined. It means I don't have an output. My formula didn't give you an output, which basically tells me that minus 3 is not in the domain of this function, because according to my rule, there is no output for it. It means minus 3 will not be in the domain. So that's really how we're going to understand this function. Okay, I'll try one more and then we graph. So let me pick, I don't know, f of 1/2. Why not? What's f of 1/2? Please, all of you be part of it so you understand this. Again, you take 1/2 and you ask yourself, where is it? 1/2 is here. If it's here, it means that's the rule that's going to be applied. So it's 2. I will get 2 times 1/2 plus 1. 2 times 1/2 is a 1. 1 plus 1 is equal to 2. Okay? All right? Now, one classmate asked me why f of minus 3 is undefined. Because to be defined, to give me an output, I should tell you what I'm assigning to minus 3. Now, minus 3 is not here. It's not between minus 2 and 1. Because on the number line, that's minus 2 and 1. Minus 3 is here. It's not between minus 2 and 1. Minus 3 is not bigger than 1 either. So according to what I'm giving you, there is no output for -3 because it's not in here and it's not in here. So my formula is not basically giving Q the output. That's why it's indefinite. It's not in the domain of my function. Okay, right. We are finding the input based on what I'm giving Q right there. Question before we go on. How do you determine that X? I just look at it. Okay, 1/2. Is it bigger than 1 or is it between -2 and 1? That's really what I do. 1/2 is, of course, 1/2 is somewhere here. It's between -2 and 1. Because it's between -2 and 1, that's the rule for it. It's 2 times 1/2 plus 1. That's what, so how I determine, I look at it. This is 1/2. I go back, where is the 1/2? Here and here. Let me give you one more example so everybody will be on board. Suppose I'm giving you f of 4. So my input is 4. So here, x equal to 4 is the input. Okay, is this bigger than 1 or less than 1? 4 is bigger than 1. And this rule tells me if you have an input bigger than 1, that's the rule for the output. So what is f of 4? It's going to be -4 plus 3, because 4 is bigger than 1, which is going to give me -1. Please ask questions because I want this to be very clear. Anybody? Okay. Part 2. Sketch the graph. Don't worry about that. Let's sketch the graph of f. Okay, let me rewrite f. Let me rewrite f here. It's 2x plus 1 as long as x is between -2 and 1. And it's -x plus 3. That's the function I'm working with for x bigger than. My question is sketch the graph. How can we sketch the graph? Okay, we have 2 different rules depending on x. So to sketch the graph, we're gonna do the following. Okay, we're gonna first sketch this piece by itself. But I'm gonna sketch it between -2 and 1 because the output is 2x plus 1 between -2 and 1. So between -2 and 1, I'm gonna totally get rid of that. Between -2 and 1, if the input is x, the output is 2x plus 1. So that's where the word piecewise comes from. So I'm going to first sketch the piece 2x plus 1 between -2 and 1, and then stop. So this is -2, and this is 1. I'm going to sketch this. So how do I sketch that? This is a line, 2x plus 1. So I need to point x, and this is the 2x plus 1. Okay, then I'm interested in it between -2 and 1 only because that's what the output is. So I said, okay, at -2, this is going to give me 2 times -2 plus 1, which is -3. And 1, this is 2 times 1 plus 1, which is 3. So at this stage, I'm trying to pick up my value. Now I said, okay, between -2 and 1, this is a line. Totally, I'm hiding the second piece. We're not allowed to see it yet. At -2, we are at -3. So that's, if you guys don't see, you have to let me know. That's -2, -3. At 1, my function takes the value 3. And because I have equality, this is going to close. So between -2 and 3, I have this piece of the graph, only a piece. I don't have the whole thing yet. That's my piece. I close it both ways because I need to close it both ways because I have equality here, equality here. So this piece is represented by this graph. Okay, now the other piece. minus x plus 3. Okay, I'm going to represent this by a graph. Okay, so let's do that. Minus x plus 3. Now, this is also a line because that's linear. That's a line. So to graph this line, I need to point. But I'm only interested in that line from 1 onward. That's the one. So I don't care about what's happening before that because my function is here. Okay, so now how we're going to do it? It's strictly bigger. So this is x, and this is minus x plus 3. Okay. I say, all right, if I take 2, because I'm interested in x bigger than 1, so this is minus 2 plus 3, which is 1. So at 2, my functions take the value 1. Okay, now at 1, it's minus 1 plus 3, it's equal to 2. It means that at 1, this is 1. At 1, my function takes the value 2, but it's open because it's strictly bigger than 1. And I'm going to sketch my line. I'm going to sketch my line. It's going to sketch my line. And that's the line. It's open, closed here because at 1, the rule is 2 times 1 plus 1. It's open for here because x equal to 1 is not included, is included up here. And that will be the graph, which is, as you see, it's piecewise, it's 2 pieces, 2 lines. 1 line, and this here is this line right there. Okay, all right. I have to stop here for sure. And you guys will take the quiz. And after the break, we definitely gonna work a lot on those type of problems on next Thursday. Okay, so the worksheet that I put online, now that you have plenty of time, please print it if you can for next, for next Thursday, so we can spend all the time working exactly on those type of problems, right? Okay, you guys can go start taking your quiz. You will have a Moodle homework this time, which is due next week. I will explain it clearly on Brightspace. So get going.